All right, so let's move into some word problems now. So this problem tells us Josh Smith's workout consists of jogging for 3 miles, then riding his bike for 5 miles at a speed of 4 miles per hour faster than he jogs. If his total workout time is 1 hour, find his jogging speed and his biking speed. All right, so there's a lot going on in this problem, quite clearly. What does jump out at me in this problem as far as trying to organize my work is I see miles, miles per hour, miles, and we're being asked for a jogging speed. So as I'm looking at all this information, what's jumping out at me is distances, rates, and times. So I'm going to try to organize my information in what we've called a dirt box, a D equals RT box, so I can just try to figure out what information do I have, what am I looking for. So as I look at distance equals rate times time, and I create this box for organizing my information, I have two situations. I have the jogging situation and the biking situation. I'm going to try to jot down some information about each. So for jogging, we're jogging for 3 miles. Miles measure distance. So I'm going to put 3 in for my jogging distance. It's a little cell there. And then rides his bike for 5 miles. Also, with the bike, miles is distance. So those are values that we just straight up know. Now we do know that the biking speed is 4 miles per hour faster than the jogging speed. Now we don't know what the jogging speed is, and in particular we're asked to find his jogging speed and his biking speed. So we need a variable for it. So we need a variable for the jogging speed. Now we do know that the biking speed rather is 4 miles per hour faster than he jogs. So 4 miles per hour faster would be x plus 4. Now be careful not to put 4x, because remember 4x would mean 4 times as fast. And that's not what it said. It just said that we're 4 miles per hour faster, so that's addition. Now we don't know anything individually about the workout time, but we do know that combined it's 1 hour. And we have two different ways of dealing with this. We could use a second variable if we wanted to, where we do the whole y and 1 minus y thing. But that's going to lead to an ugly situation that I don't really want to deal with. So instead what I'm going to do is I'm going to just jot down a little note that if I take the time that he jogs for and add that to the time that he bikes for, if I add those two things together, I'm going to get 1. So we know the equation D equals RT, but what if I want to solve that to get the T by itself? I could divide both sides by R, and that would say that time is distance over rate. So the time that he jogs for would be the distance he jogs for divided by the rate at which he jogs. The time that he's biking for would then be the distance that he's biking divided by the rate at which he is biking. And when I add those things together, I get 1. So as I look at this, what I see is a rational equation, an equation with fraction expressions in it. Fractions suck. Get rid of the fractions. So we're going to multiply both sides by the LCD, where the LCD is x times x plus 4. And so we're going to put an x plus 4 into the top of each of these fractions. And the goal here then is to get rid of the fractions. That's the whole idea. So in the first fraction, the x's divide out, leaving just 3x plus 12 as I distribute the 3. In the second fraction, the x plus 4's divide out, just leaving the 5x. And on the right-hand side, I could distribute the x across, getting me x squared plus 4x. On the left-hand side, we can combine our like terms, and then we can bring everything to one side so that the other side is 0. At this point, we could try to factor. If we can factor, awesome. If not, we use the quadratic formula. And in this case, we actually can factor, so don't forget to try that. So that's going to give us that x minus 6 could be 0 or x plus 2 could be 0. And so x could be 6 or negative 2. Now the negative 2 gets thrown out because remember that x, if we look back up top, x was the rate at which we jog. You can't really jog at a negative number of miles per hour. That doesn't make sense. With x equals 6 being our answer, let me jot that down up here. We still need to actually answer the question that was asked of us. And we actually had two questions, to find the jogging speed and the biking speed. So we wanted the jogging speed and the biking speed. And this is again why we like to organize our information in a nice, smart way. Because we can clearly see the label that x is the speed at which we jog. So that's 6 miles per hour. And the rate at which we bike was x plus 4. It was 4 miles per hour more than that. So that would be 10 miles per hour. And that makes it really easy to answer the actual question that's asked of us if we organize our information well.